Hello everyone, my name is Rohit Singhal and we were discussing about hydrocarbons. In the previous classes I already discussed about the alkanes and alkenes, and in this class we are further gonna see the another category of the unsaturated hydrocarbons, that is alkynes. So today's topic is alkynes. I have mentioned there also that alkynes is, that means there is at least one triple bond, at least one triple bond present. Triple bond is a combination of 1 sigma and 2 pi bonds, unless alkenes were a combination of 1 sigma and 1 pi bond, whereas triple bond contains 1 sigma and 2 pi bonds. Its first member, this is the first member of the list, it is termed as ethine. Do focus on this name also, ines and ines. It's also commonly termed as, commonly it's also named as acetylene gas. You must have encountered with the gas, acetylene gas. You must wondering where you have encountered this. If you have ever gone to a welding shop, so the gas they use to produce this, the gas they use to weld your whatever you are taking with you for the welding, their acetylene gas is used for the welding purposes. Not acetylene only used in the welding purpose, oxygen gas is also used. So the use of acetylene gas is used for the welding purposes. Okay. So what's the structure of this? First of all, if we talk about the shape of this is a linear molecule, means this is an one single line. Now you already know how this C single bond C is formed. Let's talk about how two double bond, how this 2 pi bonds are formed. How 2 pi bonds formed. So the pi bonds are formed by p orbitals of carbon, right? We have previously discussed this. And carbon contains 3 p orbitals, and all are perpendicular to each other. Okay, now we are going to discuss what I'm telling about the p orbitals. So now how we can imagine these p orbitals. Let's take an example of the Cartesian coordinate x, y and z. So this is a px orbital. How we can make a px orbital? This is a px orbital. Its symmetrical lobes. This is a py orbital. And this is a pz orbital. X, its y, its z. Its py orbital and its pz orbital. So and we do remember that pi bonds is a sideways overlap, right? So how this is gonna form? There is already one C single bond C, that means a sigma bond is already there. So there is one p orbital lying perpendicular to this. It I can show like this. Okay. So, this is the formation of one pi bond, this is the formation of second pi bond. In the 2D picture is not that much clearly visible. So, but this is and there is one this bond is formation with the hydrogen, and this will give C, this is one sigma bond, one pi bond with the sideways overlap of 1 orbitals, this bond will form, and this will give the structure of ethine or acetylene. So, these are the basic ideas about the acetylene also. It also has a general formula, as we have discussed. What will the general formula we have discussed about the alkanes and alkenes. Alkanes, you remember, we have CnH2n plus 2, this is alkane. Alkene is CnH2n, and alkyne will be CnH2n minus 2, where n can be 2, 3, 4, 5. It also starts with the 2 as alkyne, because there should be at least one carbon carbon triple bond, while whereas this alkane can start from the 1. Okay, so this is the basic formula and structure of the alkynes. Okay. These are the first members we can list. Okay. So, this is the basic idea about we have discussed about alkanes, what are their structures, what is the general formula of them. We have discussed the alkenes name and the general properties, same with the alkynes and aromatic compounds. Now, let us take it further and start having what the nomenclatures are, how I am naming these compounds as acetylene, ethine, methane, how this naming occurs to these compounds. So, we start with the nomenclature of this nomenclature of hydrocarbons. So, nomenclature, as we start with what are the points we need to see. First, classify whether it is alkane, classify whether it is alkane, alkene or alkyne. Second thing, see the number of carbons present in the chain, and according to them nomenclature, how this number of carbons gonna distinguish the nomenclature of the hydrocarbons. See, if there is only one carbon, it will be called as meth. These are the starting letters of the name. The name will start from this. If there are 2 carbons, that will be eth, 3 carbons prop, 4 carbon but. You have to remember this. 5 carbon is pent, 6 carbon hex, 7 hept, 8 oct, 9 non, 10. Do remember up to this 10 carbons for now only. So, this you have to remember, one carbon is called as meth, 2 is eth, 3 prop, 4 but, pent, hex, hept, oct, non, dec. Now, what the remaining part? What is the remaining part that is we need to, when it will be followed by something, na? It's obviously an improper name. So, what is going to discuss now? Another after part of the name will depend on the type of hydrocarbon present. That means if it is alkane, we are going to name it, the name will end with, the name will end with this thing I already told, A and E. If it's alkene, the name will end with ANE, and if it's alkyne, the name will end with Y and E. It's not difficult to understand also. It's not that much difficult to understand how N name already suggests what the name will end with, alkyne. So, let us form the series of the alkenes and alkynes. So, starting with alkenes, first one is CH4. The first name of alkenes is, this is one carbon, right. So, one carbon means meth. Now, what is an alkane? It is, right, ANE. How will you classify between the, okay, there is also one question, okay, how will between these different hydrocarbons, okay, this first, because the number of carbons you can directly count by the formula, but this is one thing, okay, which we need to understand how do we classify, okay. So, I have already told about the general formula. Stick by that we will distinguish whether it's an alkane, or alkyne, okay. So, let's forget that it's methane. Let's take a raw example. We don't know it is methane, okay. Let's take this, okay. We have to nomenclature it, what will be its name. There is one carbon, right, one carbon means meth, okay. Now, we don't know whether it will be alkene or alkyne. So, how do we know that, okay, there is one carbon, it will be N. How many other carbons? It's twice plus 2, okay. So, we can, so this number, the CH4 is matching with the formula CnH plus 2, and this we know is for the alkanes, and alkane nomenclature ends with N. So, its name will be methane. Let's take a second example, C2H6, okay. Now, there are two carbons, right, two carbons means 8th. Now, what will be the general formula? There are two carbons, right, there will be two carbons, okay, two carbons, and what it is, see the general formula, how we can distinguish, it's double plus 2. In alkenes it's double plus 2. In alkenes it's double of carbon, and in alkyne it's double minus 2. Simple it is, okay. So, here is, we can see that there are 6 hydrogens. There are 6 hydrogens, and 6 hydrogens means double of 2. So, these are the alkanes forming the general formula CnH and CnH2n plus 2, and it will end with ANE. Another example, let us take C2, or let us go to the higher C4H8. Okay, let us go with this. There are 4 number of carbons. 4 number of carbons, you if you do not remember, I have mentioned this 4 carbons. What is this? Bute. Okay, so you must remember this also. 4 carbon is bute. Now what it is, alkane, alkene or alkyne. Okay, so the number of carbons are 4. Okay, number of carbons are 4 and it's double. The number of hydrogens are double of hydrogen. Okay, so it's gonna form bute. That means it's an alkene, right? It's an alkene, so it ends with ENE. Okay, taking another example, let's take an example of alkyne, C3H. Okay, let's take this example, C3H4. Okay, now a number of carbon, how many number of carbons? 3. That means prop. How do we know it's alkene? The number of hydrogens equals to 2 times number of carbon minus 2, right? 3 to the 6 minus 2, so it forms an alkyne. Alkyne ends with N, so propyne. So this is how we gonna nomenclature of alkanes, alkenes or alkynes. In further classification, in further classes we will further discuss about a bit higher members of the higher members. We will discuss more examples of the nomenclature of the hydrocarbons. For now, this we have discussed about the basic idea of alkane, alkene and alkynes, their properties, their structures, the nomenclature of them. You must remember this for the nomenclature. Nomenclature only depends on the 2 things: how many number of carbons are present, first thing. Second thing is whether it's alkane, alkene and alkyne. How we going to distinguish between the alkane, alkene and alkyne? By seeing the general formula. If you don't know the general formula, it's still fine. The alkane is in alkane the number of hydrogens are double, are 2 more than the double of the number of carbons. In alkenes, the number of hydrogens are double than of carbon. In alkynes, the number of hydrogens are less than 2 than the double of number of carbons. So on this basis, we will nomenclature whether it is alkane, alkene or alkyne, and using this how we have distinguished till now whether about the nomenclature of whether methane, ethane, butene, propyne. So this is how we gonna nomenclature of these hydrocarbons. For now, this is all, and thank you so much.